Hi, my name is Joseph Levon.
My name is Kiana Harris.
And my name is Huten Ziari.
And
This is the particles of the Standard Model. And my partner Joe is going to start off with the presentation by talking about the quarks.
Okay, I'm going to reiterate the quarks. So here is the Higgs field, and for the Higgs field, it starts off with the highest mass of the quarks and goes all the way down to the lowest mass. So the highest mass is the top quark with 172 giga electron volts, and your smallest mass is your up quark with 0.003 giga electron volts. So your second highest mass is your bottom quark, which is basically the most notable because it is a product of pretty much all your decays from your top quark. Your charm quark and your strange quark, when composed together, creates a subatomic particle called a hadron. Your down quark is pretty much your second lightest quark, and it is a major constituent of matter. Composed with your lightest quark, which is your up quark, it forms your neutrons and your protons of your atomic nuclei. And next to present the models of your leptons is Miss Kiana Harris.
now I'm going to be talking about leptons. And leptons are the elementary particles that does not take part in strong interactions. And the lepton families are tau, muon, electron, and neutrinos. And electrons, it belongs to the first generation of a lepton. It is a subatomic particle with a negative elementary charge. It has no known components or substructures. Then there's tau. Tau is also similar to electron with a negative electric charge, but it is a heavier version of electron. And then there's muon. Muon is also similar to electron with the electron charge of -1, but it also has a greater mass than an electron. And it also is an unstable subatomic particle with a lifetime longer than many other subatomic particles. Then there's neutrinos. Neutrinos is the lightest fundamental particle, and it only interacts only with the weak subatomic force and gravity. But in order to create neutrinos, it has to go through a weak interaction. And that's all about leptons. Now I'm going to pass it to Huten.
I'm going to be talking about the forces. And throughout nature, there are 4 forces, but in the particles of the Standard Model, we only talk about 3 forces: the weak nuclear force, the electromagnetic force, and the strong nuclear force. For the weak nuclear force, it's a fundamental force of nature, and it governs the decay of unstable subatomic particles, and it also initiates the nuclear fission reaction that fuels the sun. Z and W, which are also bosons, are part of the weak nuclear force. The electromagnetic force is a type of force that happens between electronically charged particles. Photon, which is basically light, is the force carrier for electromagnetic force. And for the strong nuclear force, it's the force that holds everything together in the nucleus. And it binds everything together in the nucleus, and the amount of force that it takes is 1 femtometer, and 1 femtometer equals 10 to the negative 15 meter. And for the strong nuclear force, gluons are the force carriers, and there are 8 types of those. And the last force that we don't really talk about in this model is the gravitational force, and that's because it's negligible because the masses here are so small that it has barely any effect on them, so we neglect that. And that concludes our presentation of the particles of the Standard Model, and thank you.